Today we're going to use our trigonometric ratios that we've learned, along with our calculators, to solve for missing sides of a right triangle. And the way we attack this is, first of all, we take a look at the fact that we're given a particular angle. In this case, we're given a 63-degree angle. And from there, we can label all of the sides in this right triangle. Obviously, the side opposite the right angle is the hypotenuse. The side opposite the 63-degree angle is our opposite side. And then the side next to the 63-degree angle is our adjacent side. And from here, we can set up an equation with one of our ratios. In this case, the sides that have labels on them are the opposite side and the adjacent side. And so that leads me to want to use the tangent ratio. So the equation that we'll write is the tangent of the angle, which is 63 degrees, is equal to the opposite side, which is x, over the adjacent side, which is 6. Now, this is where your calculator comes in. What we're going to do is we're going to use our calculator to figure out the tangent of 63 degrees. So you can see I've got a picture of Texas Instruments calculator here, and I've typed in tangent 63. Before you do that, you have to make sure a couple of things are in place. Because we're working with angles measured in degrees, we need to make sure that we're in degree mode. And usually it'll say DEG somewhere on the screen. If you're not in degree mode, you can usually hit the DRG key until degree shows up. Once that happens, I use the tangent key to get tangent to show up on the screen, and then I type in 63 and close the parentheses. Once you hit equals, you're going to get the decimal version of the ratio for 63 degrees, the tangent ratio for 63 degrees. It comes out in the form of a decimal because it's an irrational number. It's a long decimal. So you can see when I hit equals, I get the decimal version of the tangent ratio. And what I'd like you to do is round that off to 4 decimal places. So in this case, that means count over to the 5th decimal, which is a 1, and then either round up or down. In this case, we'll round down. So I'm going to use the value 1.9626 and replace the tangent of 63 degrees with that value. So I get an equation 1.9626 equals x over 6. To solve this equation, we simply are going to multiply both sides by 6 to isolate x. And I end up with x is approximately equal to, my calculator says 11.7756, and I'm going to round that off to 1 decimal place and call it 11.8. So the value of x, the missing side, is 11.8 units. And so that's the strategy that we'll use to solve problems today. We will identify the angle that we're working on, make sure we label the sides correctly. Remember, this was opposite and this was adjacent. This is the hypotenuse, but it doesn't even have a label on it. I chose to use the tangent ratio because it is opposite over adjacent. And then we're going to have to use our calculator to get a value for the trig ratio that we write down. So in this case, tangent of 63 degrees, we use the calculator here to get 1.9626, and then we can solve the equation. Ultimately, we're trying to get this value for x. That's our goal. In this case, it was 11.8. Let's try a couple more quick examples. So in this triangle, I'm given the value of 64 degrees for angle B. The longest side here, 11, is the hypotenuse. I don't know the opposite side. It's blank. But I do know that the adjacent side is x. So I want to find a ratio that deals with adjacent and hypotenuse. And the ratio that happens to deal with adjacent and hypotenuse is the cosine ratio. So I'll write an equation. The cosine of 64 degrees is equal to the adjacent side, which is x, over the hypotenuse, which is 11. Again, remember, this is adjacent, and this is hypotenuse. And I chose cosine because I knew that it would involve the 11 and the x, or the x and the 11 in this case. Once you have this written down, just like the last problem, we want to replace cosine of 64 degrees with a decimal number. And for that, we need our calculators. When I type cosine 64 degrees on my calculator, making sure that it's in degree mode, I get 0.43837, which rounds to 0.4384. And then again, like the previous problem, to solve this, I simply have to multiply by 11 on both sides to get the 11 to cancel. And so I'm just going to do 11 times my decimal number, which happens to be 4.8224, and I'm going to round that off to 4.8. So x is approximately 4.8 units. And so we've solved for the missing side, right? The missing side is always the one that has the x on it, in case I didn't make that clear. So we identify what we're given. In this case, we had the adjacent and the hypotenuse. They have labels on them, the 11 and the x. And so we can write this equation, replace the cosine ratio with its decimal equivalent, and then solve for x, like we do in most other algebra problems. Let's do one more example, and then we'll wrap this video up. So here we have a right triangle with a 45-degree angle. Angle B is given. Oops, I just moved that around. And my phone just beeped, of course. Awesome, but I'm not going to erase this. I'm going to keep rolling. There's no blooper reel on this one. So we're given this 45-degree angle, angle B, and we want to identify the sides that are given. So this x happens to be opposite the B. The side that's opposite C is the hypotenuse. We always know that. I'm just having a rough time with this last slide here. There we go, hypotenuse. And so we need a trigonometric ratio that deals with the opposite and the hypotenuse. That happens to be the sine ratio. So I'm going to write out sine of 45 degrees equals, and then its opposite, which excuse me, which is x, over hypotenuse, which is 3. So sine of 45 degrees equals x over 3. And then what I'll do is convert sine of 45 degrees into a decimal number from my calculator, sine of 45. It rounds off to 0.7071. We're always going to go with 4 decimal places on this one. 0.7071 equals x over 3. And again, we're pretty lucky to solve this equation for x. All we need to do is do the inverse operation to eliminate the 3. And I'm going to multiply 3 times 0.7071, which is 2.1213, which rounds off to about 2.1. So our missing side in this problem is x equals approximately equal to 2.1. We'll round them to 1 decimal place for our final answers. Okay, so there's 3 examples of using trigonometric ratios and our calculators to solve for a missing side. We're going to work on some problems in class today, and I wish you the best. And I can obviously help you if you have other questions. Take care.